Alexa, man, you're trash.
Yo, I'm actually about to ball on you so hard, bro.
Nah, Nitin, this is how you do it. This is how you do it.
So now that we've seen the shots, we can plot them on this graph. So we're assuming that everybody shot from roughly around their height. So I shot from 6 feet tall because that's how tall I am. Ali shot from a little under 6 feet, and Sherjeel shot from 4 feet tall because that's how tall he is. So my shot was a straight horizontal line because Ali's basketball hoop is 6 feet tall for some reason, because he got it at like a garage sale that was run by dwarves. So the line for that is y equals 6. It's just a straight line. So now we have Ali's shot. Ali's shot had a really high arc. So the A value for Ali's shot is -1/3, which is pretty big. So the greater the absolute value of that A value, the higher the arc is going to be. So, and now we have Sherjeel's shot. The A value for Sherjeel's shot was around -1/6. So his shot didn't have that high of an arc. See, it only goes up to here. So now what we have to do is, let's suppose that John is 3'6" because that's roughly his height, and Ali moved his basketball hoop into the TMSA gym. The ceiling in the TMSA gym is about 10 feet tall. So what John has to do is, John's used to shooting a really high arc. So John has to make it into the hoop with as high of an arc as possible, but he can't hit the ceiling. So we have a few constraints for that. So to satisfy the point 0, 3.5, C has to be 3.5. Now what that means is, this point is where John is shooting from, see, because he's 3.5 feet tall. So the ball has to start right there. So to satisfy the point -8, 6, 64A minus 8B has to equal 2.5. Now what that means is, -8, 6 is where the hoop is, so the ball has to end up in the hoop. So if we plug -8 in for the x and 6 in for the y, we can simplify and get this equation. So to satisfy the ball staying at least half a foot under the roof at all times, so that means we can only go up to 9.5 feet tall. So the y-coordinate at the vertex can be at most 9.5 because the vertex is where the ball is going to be the highest. So if we plug that in for y, we get, or if we plug 9.5 in for y and make it an inequality, we get ax squared plus bx is less than or equal to 6. So we know that the vertex, the x-coordinate for the vertex can be found by the formula -b/2a. So we can plug that in for x here, and it simplifies out nicely to b²/4a. Okay, so sorry guys, there's a correction that needs to be made. So for this equation, if you plug in -b/2a for the vertex, you get -b²/4a, not just b²/4a. It was fine in the graph. b²/4a is less than or equal to 6. So now the a value, if it's positive, it's going to be kind of like this. It's going to be a parabola. So if it's negative, it's going to look more like a regular basketball shot. It's going to be arced, and the highest point is going to be like the vertex. So a has to be, oh, there's a typo there. A has to be less than 0, so that it's like a normal basketball shot. So we can then optimize by graphing to find the highest arc for John's shot, while still starting from where he starts and making it into the hoop and not hitting the roof. So if we graph all this, so this is the first constraint right here, 64x minus 5y equals 2.5, that ensures that the ball is in the hoop. So this is, oh yeah, and also we substituted x for A and y for B, so that we could actually graph it and solve it by graphing. So then the second one, negative y squared over 4x is less than or equal to 6. That ensures that the ball doesn't hit the roof. And then the last one, x is less than 0, that makes sure it's like a regular basketball shot. So if we take all these factors into consideration, the point with the highest absolute value for x is right here. So if we plug this value in, negative 0.292 for x and negative 0.2 or negative 2.646 for b, or this is for a and this is for b, we can put that in here, and yeah, it looks like John's shot. It's starting from where he is, it makes it in the hoop, and it's at least half a foot under the basketball, or under the ceiling.